Hi everyone, greetings to all. This is Dheeraj Nayal, Head of Corporate Development at DevOps Institute, part of a PeopleCert Group company. And I'm the host for this Skill Up session, which we do with our audiences to provide uh, new skills, new knowledge, new ideas, and new learning as part of the discussions with industry leaders and thought leaders. And the topic today is cloud native platform engineering. And we have a great set of panelists today who are joining us. Unfortunately, with some of the technical issues, you might not see some of the panelists on the video, but sure enough, they are here in terms of providing their inputs as well as their expertise through their audio as well as different set of discussions. So please feel free to share in your comments, your questions regarding any of the discussions points, and we would be happy to take them as part of it. So, to introduce the panelists, first up we have Adriana, the senior developer advocate at Lightstep from ServiceNow. And then we have Adarsh, a senior industry principal consultant at Infosys. And last but not the least, we have BMK, transformation architect at Section 9 and also the DevOps Institute ambassador. So before we dive into the topic of discussion, I will invite each of our panelists to provide a brief introduction about themselves and also provide a key aspect about the passion which drives them ahead within this industry so that our audiences can also relate as part of the human self DevOps, which we call it as part of the larger community. So I'll start with you, Adarsh, to give a brief intro and talking about your passion areas as well. Over to you, Adarsh.
Thank you, Dheeraj. So, myself, Adarsh, close to 19 years of work experience, and I've been working in the DevOps and SRE area for last 7 to 8 years. In fact, I lead the consulting practice and close to 200 plus consultants all across the globe, bringing in and assimilating a lot of knowledge, which we cross pollinate and share across the board. I've led some large scale transformations on DevOps and site reliability engineering, specifically in the Asia Pac region. And currently, as I speak, I'm working for one of the Australian clients sitting in Sydney. Um, so from a passion areas perspective, the what drives me, and this is where consulting background has helped because I was typically first 6 to 7 years of my career I was into delivery of things. But then when I moved to consulting, what excites me is that every day there is a new challenge. And with evolving technology, with such a rapid pace of change that is happening in our industry, it just motivates you every single day to get up and then go ahead and solve the client's challenges and problems. It could be tools, it could be processes, it could be culture, it could be people. But then at the end of the day, what we are doing is helping transform the clients, and I feel proud to be part of such journeys. So I think that what drives me, and that is what keeps the passion going. Short and sweet about me. Thank you.
Thank you, Adarsh. Over to you, BMK, to provide a brief intro and talking about your passion areas, please.
Yeah, thank you very much, Dheeraj. I'm excited to be here, and thank you, Adarsh and Adriana, the fellow panelist. And myself is BMK. I'm based out of New Zealand, Wellington, and it's 3 o'clock in the afternoon. I come from a developer architecture background, so been in this space for quite a while now, and I am one of the earliest ambassador, um, one of the ambassador for DevOps Institute, and my passion is actually how do we use technology to help people. It's internal and also external. Internal, actually, your developers, your architecture, and also external, your customers. That's where my passion is. Over to you, Adriana.
Hey, I'm Adriana Villela. I am calling from north of Toronto, Canada. I'm on holiday this week, so I'm calling in from a hotel room with very spotty 5G service. So apologies, I can't be on camera. I've been in the tech space since 2001, so I've been doing this for a while. Started my career doing Java software engineering. So spent lots of time doing that, but got into I led a DevOps transformation at a major Canadian bank. And then I I managed a platform engineering team and an observability team at Tucows for a bit. So transformations are not new to me. Definitely know what's involved as part of them. Never an easy thing. I'm super passionate about just delivering software properly. I feel like, especially in the DevOps space, I feel like we've nailed CI. We haven't nailed CD yet. So I really want to make sure that we continue moving the work forward in that direction, because I think we have like all the tools and practices around that. We just need to keep pushing it forward.
Well said, Adriana. So thank you so much again to each of the panelists to provide their time and expertise in sharing valuable aspects around cloud native platform engineering. So to kick off, I think for audience references also, it's very important that we break out, first of all, cloud native and platform engineering, and then kind of club it together as part of the current industry standard. So I'll go with each of the panelists here and talk about a brief definition from their end, what they mean by cloud native and what they mean by platform engineering as such. So I'll start with you again, Adarsh, to share your inputs around that.
Thank you, Dheeraj. So I think, yeah, like you rightly called out, let's probably look at the cloud native side of things, look at the platform engineering side of things, and see how we can marry the two together. So from a cloud native perspective, we are looking at deploying and managing applications that are entirely built on cloud. So when I look from a technology lens, we are looking at things like containers, we are looking at things like, microservices, immutable infrastructure, all that runs on cloud. Now let's come to the second aspect, the platform engineering. And that is where platform engineering is actually a practice where you look at building a common platform. In fact, building and operating a common platform, which serves as a product for a lot of your delivery teams. And the objective is that we move towards a self-service model. So now, if you kind of look at the two together, what we are looking at is platform engineering, which is helping in improving the developer experience. And this has become a vehicle for easing out your cloud native journey. So that is how I'll summarize and put it. Back to you, Dheeraj.
Thanks, Adarsh. Over to you, BMK. I know cloud native is one of your passion areas, so keen to hear from you around cloud native definition and the platform engineering definition. Please go
Yeah,
ahead.
thanks very much. Thanks, Dheeraj. I'm a CNCF ambassador for New Zealand, so I closely work with the some of the CNCF team, and also the ambassador network, and also people like Adriana who are very active in the open telemetry space as well. So, which is really exciting for us. So I think in every software organization, and there are two core functions, like the emerging models that we see now is like, one is a product engineering where you develop applications, customer focused, internal customer, external customer focused. And another one is actually a platform engineering where like you are consolidating the platforms, tool, infrastructure, and automation, everything, like where you provide a self-service capability for your application developers to leverage the software defined anything and everything, and then how you can quickly deliver value to your business, how you can quickly deliver value to your customers. That's becoming a main focus area. So from a platform engineering point of view, I mean, I agree with the point that is like they focused on developer productivity and developer experience. That's the main focus, and also helping developers to be, accelerate the application development and delivery and deployment. Now, that is one thing from a platform. It's not just about application delivery, but also about like an understanding from the operational point of view as well. Like, what is this involved in running the application on production? What kind of insights that you get from, and how the feedback is coming and flowing into your software development life cycle in terms of like your feature, how it is being used by customer, or if there is an issue with your software. So this is the focus on the platform, the cloud platform engineering perspective. So when you say cloud native, what does it mean? Is actually anything and everything is actually defined as software, right? So you have ecosystem of tools and platforms within your organization, whether you're talking about an on-prem, or you're talking about open public cloud, or you're talking about hybrid cloud, it doesn't matter. And when you are saying I'm developing a cloud native application, in the sense like, I know my application is based on distributed architecture. It's either a serverless or it is a microservices kind of an application design, and I'm running on highly available platform and systems. And then anything is defined as automation, and actually defined by APIs, and defined by CLIs, and all this stuff. So this is where actually the difference comes when you talk about cloud native, and platform is like an encapsulated, abstracted the complexity of underlying things, and give only a self-service capability for your developers or engineers to provision what they need, and accelerate the application development.
That's very well said, BMK. So thank you for that. And over to you, Adriana, to share your aspects around cloud native and then platform engineering.
Yeah, so I think BMK put it really well, talking about how cloud native is about being able to codify all the things. I think one thing that cloud native gives us over, just our regular old data centers is that we don't have to worry about, like, we need more compute power. No problem. You don't have to like rack a new server, right? You don't have to worry about hooking up the like the electrical lines for a new server. I've actually had to do that where we, not me personally, but like we needed new servers. We had to like tell the folks at the data center, yeah, we need to rack new servers. We need all these extra considerations. And cloud kind of lets us forget about all the things, because there's some magical things behind the scenes that happen where like that compute power is just automatically available to us, and all we need to do is like use those API CLIs to basically provision that infrastructure for us, which is awesome. Now, for me, platform engineering, I see it as like in the same way that one can view SRE as the implementation of DevOps. I see platform engineering also as the implementation of DevOps, and it's really more, I see it as an extension of SRE, where SRE we're concerned primarily with the external customer. Platform engineering takes it to that extra level where we also can care about the internal customer, which is the developer. And so again, what Adarsh and BMK were saying about that self-service aspect, I think super important, because developers don't want to wait around to provision resources that they need so that they can do their jobs. And platform engineers don't want to spend their lives provisioning resources for those developers so that they can do their jobs.
Thank you, Adriana. I think all of you have put it really well together in terms of the cloud native and the platform engineering. And now coming back to the real topic for today, which is the cloud native platform engineering, which essentially refers to the practice of designing, developing, and maintaining a software application infrastructure that are specifically built to leverage cloud computing environments and follow cloud native principles. So for audience references, who does cloud native platform engineering, why it is so important, what are the key principles? I think these are the aspects which makes a lot of sense to understand and align their understanding based on what they think about cloud native platform engineering. So I'll again go in a roundtable format to each of the panelists to uh, pick their thoughts about and their expertise about what they think about cloud native platform engineering, what are the key principles, and who does it in terms of the different organization in different sectors. So I'll start with you, BMK, to talk about it this time.
Sure. Thanks. I think the shift in fundamentally in application development, if you look at from an architecture point of view, is like you traditionally developed a two-tier architecture or maybe a three-tier architecture. Like you have a front end, you have a middleware, and you have a back end. This kind of things. And generally, the systems in the olden days are actually, or even nowadays, like you see a big monolith systems are designed and following a waterfall model, upfront big design, and then you develop a big system, you test it, and then you deploy it to production. You operate it. That kind of pattern is still valid. I'm not saying no, because sometimes that kind of a system design is actually more appropriate for some of the particular use cases. But at the same time, from looking at systems, like as we speak now, we know that this particular platform, the platform that we're using for our webinar is running on your browser. And as we speak, as we present now, your browser is getting updated behind the scenes. And it happens like seamlessly. Of course, there are some tools and platforms and DevOps practices and all is involved. So what happens is actually you could look at from how making a small changes, improvements can be quickly delivered to your customer. And this is where the whole paradigm shift comes in, actually breaking the bigger system into smaller chunks, similar to like if you ask someone, the people often talk about like doing a baby steps and taking one step at a time and solving one problem at a time, similar approach. Instead of changing, what happened traditionally is making a big change in your monolith system and getting tested for 2 months and then taking 1 month for deploying in production. Those kind of days are gone. Actually, now what you want is you give the build capabilities in your organization where you are ready to deploy a change or a feature or a bug fix or even a security patch as and when you need it, right? And that gives actually a tremendous an opportunity for business to innovate and accelerate their innovation and product delivery to their customers. So I think that is more important. What comes with actually the cloud native kind of the concept and the ecosystem, the platforms and the tools and all this stuff.
Thanks a lot,
So
BMKs.
yeah, I'm just
Yeah, please
I'm
go
just saying. So that's one part of it, right? Like so, this is cloud. So you need this is actually a shift in your thinking, shift in your architecture practices, shift in your engineering practices, shift in your platform and operational things. It's not in the sense like your old techniques doesn't help you to operate in the new model, and you need to learn new skills and you need to learn new way of doing things. And this is what actually the cloud native is bringing. Like you look at how do you store your secrets, you look at how you observe your systems, you look at how you deploy automated way your infrastructure and provision them, or even like probably if you want to dismantle something and bring something from a scratch in no time, like you can do that, and building highly available system. And all these things comes with actually possible because of the automation capability that comes with actually your cloud native perspective. I think that is the biggest boon for our information technology organizations or software organizations within the enterprises who can leverage all this concept to speed up the value delivery to the customer. So at the end of the day, you need to remember this. Why you do all this? Why you are running so fast? Why you want to go fast? You want to go fast. By the way, you can deliver value to your customer. As early as possible, as quickly as possible. And these capabilities, these tools, these platforms, these concept and mindset is helping you to achieve that.
Again, very well put, BMK. And like you said, and to summarize, I think the key aim of cloud native platform engineering is to enable organizations to take full advantage of cloud computing capabilities, enhance developer productivity, increase system reliability, and accelerate time to market while effectively managing cost and optimize resource utilization. So I think there is a lots of key insights being shared from each of the panelists, and I'll now uh, come back to you, others, to share your aspects around cloud native platform engineering and why it is so important and who does it. Over to you, others.
Thank you, Dheeraj. So I think what is important is that when we you look at cloud native, we take the advantage of all the modern infrastructure that we have and the architecture. So basically, to build this common platform as a product for the teams, what we have to do is we have to keep two things in mind. So one is that we implement a lot of these reuse tools and self-service capability. We talked about self-service capability a while, and BMK and Adriana also touched upon it. So you're looking at the automated infra operations and managing all of this on your Elastic Cloud infrastructure. So whether it could be about configurations, it could be about your networks, it could be about the security, the data handling, your service meshes, and likewise, and bringing in as much as automation as possible. And the second aspect here is that you standardize your tools, your components, and your whatever native cloud services that you are using so that you have a very consistent approach towards your deployment across the platform. Now, if you bring these two aspects together, then that helps in creating that cloud native platform that everybody is aiming at. Now, to answer your second question on who does it, I think for that we probably will have to understand a bit more on what cloud native platform engineering actually comprises of. If I want to break it down into, let's say, smaller chunks, so one area that I am looking at is infrastructure. So in some of our conversations, we talked about infrastructure, right? And again, within infrastructure, we can break it down into three parts. So we have containers. So we have containerization. We will have your infrastructure as a code, which is a very key element. And then, of course, you have cloud. Then you look at a second aspect, which I will call as, it's kind of a broader umbrella. We call it continuous improvement, but under it, some of your aspects across CI, continuous integration, continuous deployment, or continuous delivery in a lot of organizations, continuous testing, and finally continuous monitoring. So all of this you can club under a continuous improvement umbrella. And the third is security. And underlying all of these three, you will find, horizontals like, for example, the best of the breed engineering practices and metrics. So if you take a look at this kind of a comprehensive view and a diagram of, let's say, cloud native platform engineering, the people who are well versed and cutting across this are the people who are going to deliver it. So to answer your question, who delivers it? It is these set of people who understand the infra, the CI, CD, CT, CM components, security components, have a good sense of the best of the breed engineering practices and the right kind of metrics are the people who are going to deliver it. Now, I'll give you a very interesting example on how in an organization. So I used to work for a telco organization in Australia, and how over a period of time they moved from a model where they started with, let's say, one platform team. There was a one DevOps team. The platform team would roll out the services of the platform. The DevOps team was an enabler. They acted like a conduit between your development teams and your platform, and they did hand-holding exercises for the development teams. Because, for example, if I am deploying to, let's say, a Pivotal Cloud Foundry, as an application team, I will not understand if I have to make a blue-green deployment, what changes I have to make to a manifest.xml file. So the platform engineering team would be responsible for rolling out PCF, creating org spaces, sharing secrets for various teams that they can access, and then they can do the deployment. But then the changes to the manifest.xml file in, let's say, a Bamboo or a Jenkins or an AWS will actually be orchestrated by this DevOps team. Now, over a period of time, over 7 to 8 months of time, this DevOps team, which, and by the purpose for creating the DevOps team was ephemeral. So it has to be there for some time. And after that, we have to shift the responsibility and onus back on the development teams to manage the, CI CD work. So which is what exactly happened. And then this DevOps team actually graduated to SRE, Site Reliability Engineers, because they were very well connected in the system. They knew a lot of enterprise applications and likewise. So if you look at the journey for this client, which is over 2 years, so today they operate in that complete hub and spoke model, where you have your platform team that rolls out the services for the platform. There are feature teams who are directly consuming the services from the platform, and there is no DevOps team per se. So these DevOps engineers that used to be are all now part and ingrained as part of a pods or the feature teams that you call it. And now there is this SRE layer, which typically will help in improving the reliability of the services and likewise. So this has been the kind of the journey for some of our clients. So I hope that answers your who does it. Back to you, Dheeraj.
Thank you. Thank you so much, Adarsh. And I think you put it a good segue talking about SRE because I'm sure Adriana would be keen to talk about the scalability and resilience and the observability aspects of cloud native platform engineering. So over to you, Adriana, to share your aspects around that.
Yeah, totally. So I guess main thing I want to address is, like we talked a lot about self-service with respect to platform engineering, which I think we all agree is like a huge plus, a huge must in platform engineering. And I think the thing that makes it super important is because it does two things. As I mentioned earlier, it empowers developers to do the thing that they need to do without waiting around for your platform engineers to do stuff. But it also empowers your platform engineers because, as I said earlier, you don't want them constantly like fulfilling these requests. They need to use their time more effectively to do things that are probably way cooler for them, like, focusing on security, which is something that I think we often talk a lot about, but many organizations still kind of, unfortunately, they shift right instead of shifting left on security. And I think platform engineering gives us those opportunities to like really focus on security, especially like with things like policy as a service, right? With Open Policy Agent, for example. It allows platform engineers to focus on things like observability, on things to make their systems more observable and working in conjunction with developers and testers to help make systems more observable. I think also, Adarsh, you mentioned about like standardizing on tooling, which I think is extremely important. I think the whole self-service movement for platform engineering allows us to do that as well, because now you're basically putting guardrails around your systems. You're protecting the system users from themselves, which is extremely important. And I mean, I've been in organizations where they've adapted this whole view of like, oh, well, let's all use the technologies that make us happy and productive. And that's lovely, like until the organization starts to scale, and then you realize that things start falling apart pretty fast. So that standardization is super important. I think platform engineering can really help to put that standardization into place, to build in that compliance. And I think the folks that make that happen are the platform engineers, but I think also in conjunction with the developers and also with the security folks, because you need that feedback loop from all those different organizations so that you can build tooling that's actually going to properly service the organization.
Thank you so much, Adriana. So I think each of the panelists not only described why cloud native platform engineering, but also have described several benefits for organizations who are adopting this approach, talking about scalability and elasticity, talking about agility and time to market, cost optimization, resilience and fault tolerance, improved application performance, flexibility and portability, enhanced security and compliance. And there are several other benefits which are there. And I think collaboration and team efficiency, which talking about developer experience, is another aspect of that as well. So I think what next segment is also kind of aligns with which each of the panelists were sharing about DevOps, SRE, as well as the cloud native platform engineering aspect. So how these actually work out together, how are they related or how are they different? So these are some of the common frequently asked questions which we get from the community through different channels as well. And I think it's good a way to understand from each of the panelists here that how is DevOps, SRE, cloud native and platform engineering related? Is it the same or different? And how best to work with each other or together as part of it. So I'll start with you, BMK, to talk about it from your side. Over to you, BMK.
Yeah, thanks, Dheeraj. I mean, whenever I hear these kind of questions, I chuckle in my head, see that people also ask this question whether DevOps is different to platform engineering, whether DevOps is dead and platform engineering is taking over. And I think a lot of people, they use interchangeably as well, like those kind of terms, right? You need to understand DevOps is kind of it's kind of a mindset, and it's kind of a momentum we need to understand, similar to Agile, and because there are a lot of other things within that framework, within that mindset, where you come like your tooling, platform, capabilities, what you want to build, etc., etc. Right? So you need to really understand. It's not. I'm not seeing it's like a two different things. Whether you're operating on a public cloud, whether you're operating on a hybrid cloud, or you're operating on an on-prem, in the platform engineering mentality, or providing platform as service kind of a capability for your internal developers, then you are heavily relying on automation. That is number one, right? And when you say that what I'm going to automate, then obviously, as Adriana mentioned, like you're bringing some kind of a standardization into your organization, and especially these kind of things are really helps the large enterprise organization. So because you see a plethora of tools and frameworks and programming languages, database offerings, vendor tools, you see them, but what actually the platform mindset brings you is actually consolidating that, and then giving a standard set of interfaces for your developers. So for doing that, you need actually the cloud native technologies to help you out in doing that, right? For example, you need a software defined concept, like your programming, your APIs, your CLIs, and your capabilities to monitor, observe the system. And when I say observe the system, it's not like opening the browser and looking at the UI or looking at some log files. You need to also have some kind of capability where tools can help you whenever you breach SLOs, right? Like then it can give you some insights into it, and then you can start looking at it, what is going wrong. What we call Adriana, in the telemetry space, we call MELT, right? You call it about metrics or measure events, logs, and traces, like those kind of things, where you need build the right capability, keeping the developers as your customers, your engineers as your customers. Like you're building platform for your customers. Who are your customers here? Your customers are your internal developers who are leveraging your platform. So that's actually the shift here, and that's the thing. So in my view, you look at platform engineering as actually a product that you build for your developers to leverage, and that needs capabilities, and those capabilities are provided by tools which are cloud native in nature, right? Because if you do not have an automation in place, for example, if you talk about a tool, maybe 15 years before we used a particular tool in our environment, and if the tool is not interconnected with the API, it doesn't expose API, it doesn't have capability to define the system in a software defined way. For example, can I use some kind of a declarative programming to scale the system, or block the system, or push the changes for a particular thing? For example, if I need to do a VPC change, I can write a script for AWS, right? Or Azure platform. Instead of somebody going and manually unplugging or plugging something from their network. So you need to understand cloud native concepts gives you that kind of a capability that comes with the ecosystem of tools, and a lot of vendors are working in this ecosystem. There are a lot of interoperability between these tools are coming. So you need to understand these are not too different. You are leveraging those cloud native capabilities to build your platform, and the platforms are built by platform engineering teams, owned by platform teams, and your customers are your developers.
Thank you so much, BMK. And I think providing a whole ecosystem perspective is quintessential while understanding the overall cloud native platform engineering landscape. And thanks for sharing that CNCF landscape as well, because it's a bit overwhelming, but also provides a good understanding from audience perspective, the scalability and the kind of ecosystem it is developing through different projects as well. So now I'll go to Adriana to share her aspects around how is DevOps, SRE, cloud native, platform engineering related. Over to you, Adriana.
Yeah, so my view on these things is I see like DevOps as the practice around it. I'm a little bit of a purist, and I do feel like DevOps engineer. I'm sorry to say, I don't feel like that's the best use of DevOps. I see DevOps as the practice, SRE, platform engineering as the implementation. I see platform engineering, as I mentioned earlier, I see it as an extension of SRE, where now we're not only concerned for external customers, we're also concerned for our internal customers. I think being able to leverage these automations, as BMK was saying, like really leaning heavily on that is really what makes like kind of gives the cloud native superpowers, and so that empowers the platform engineer to execute on these things as well, right? And it's basically set up for us in such a way that we, as I said earlier, we don't have to carry about the innards. We're just dealing with APIs. We don't worry about who's racking our servers anymore. We can focus on the cool stuff, right? So our platform engineers can focus on the resiliency of our systems and figuring out like the best way to scale our systems so that we're not either expending too many resources or not using enough resources. I think one way that platform engineers can really assist in the cloud native aspect is making sure, I think cost overruns in cloud, especially if you've ever like run your own like personal account on any of the major public clouds. It's a little shocking when you leave your Kubernetes cluster running overnight and then you get the bill, the next month and you're like, oh, maybe I should have spun that down. Whoops. And I think I think also like when we're using these tools, like working for a large organization, it's very easy to forget that there's a cost associated to it, right? Because it's like, well, it's not our money. And I think platform engineers can really help with that by putting in, again, some of those guardrails to ensure that we don't run into these cost issues, so that you don't end up spending, $1 million because you ran this massive query that you didn't expect was going to happen. And I speak from this happened to a colleague of mine where they had no idea, like they were running this massive query. It cost them $800,000, and so, well, platform engineering team learned pretty fast that you know what, we should maybe make sure that we're not that we're keeping an eye on our spending. So those are my thoughts around that.
Thanks a lot, Adriana. And I think it also kind of teed up nicely when we were talking about cost optimization as part of one of the benefits around cloud native platform engineering. And again, there are a lot of several benefits around that, but also the distinction and the collaboration between different practices and different frameworks are really essential in order to advance the benefits around that. And last but not the least, sorry, BMK, you were saying something.
Yeah, I just wanted to add, I think Adriana provided a great perspective into that. Like, one thing that I just want to touch from I just want to add one line to that. See, if you look at look at what's happening at this space of the tools and capabilities with the public cloud adoption and all these things that are happening, there are thousands of new services that you have in each and every public cloud options, right? Like, even with there are a lot of tools in vendor ecosystem, there are a lot of tools on the public cloud offerings. Now, imagine that in 15, 20 years before, or even 15 years before, a developer who's writing code, he needs to understand the application design, where I have to deploy this on the infrastructure, what that infrastructure configuration needs to be, how do I secure them, where my databases are running, what is my connection string for the database, how do I do connection pooling, and all this. So it means the amount of things that you need to learn, in terms of your cognitive load as a developer to put together a system and to operate on is actually massive, right? Now, what the platform teams are doing now is they are abstracting this from you and giving you that headspace So by the way, you can focus on the real business problems that your business is asking you to solve, or your customers are asking you to solve. So by the way, the platform team offloads those things from you. So your focus is purely on, okay, me writing an application, maybe a React or a SPA or a middleware API or whatever it is, instead of worrying about how do I put together a Kubernetes cluster, how do I look at from a cost perspective, how do I look at from a security perspective, what kind of a configuration I need to have, where is my key vault for this. So you have I always say like this is actually we are moving towards more composable architecture space, right? Like you combine things together. Your platform teams gives you the capability similar to what your McDonald's fast food chain gives you. It gives you the burgers in a different flavor in your cart. So you choose what you want and start composing and start leveraging. And that's the speed what it gives you. That's the perspective that I want to add. Sorry.
No, thanks a lot, BMK. And I think that's the kind of perspective our audience are also expecting to understand from a broader view perspective as well. So really appreciate that. And now to you, others, I think you have seen multiple projects with multiple clients around DevOps, then with SRE and now with platform engineering. So it would be interesting to hear from your side about each of these aspects and how they are related from the industry perspective. Over to you.
Thank you for that. So I think the trend that I have seen is when organizations have reached to a certain degree of maturity on DevOps, that is where they are starting to move towards platform engineering. And I'm talking about large and complex enterprises. So while the lines are very blurry still between DevOps, SRE, and platform engineering, and you will see a bit of an overlap, but I think what is emerging is very clearly three distinct flavors, and you can break this down into if you look at again the broad categories to term these together. So you can look at, say, for example, what is the focus and responsibility for a platform engineering team versus a DevOps and SRE. You can look at the kind of metrics that they are looking to target, and then you can look at what benefit they will provide to the organization. So for example, if I am talking about platform engineering, I am looking at building and maintaining this platform that is hosting the software. When I'm looking from a DevOps lens, I am looking at the dev and the ops working together, bridging that gap between them, and then making sure that you have your smooth deployments. And when I'm looking from an SRE perspective, I'm looking at reliability, scalability, efficiency of my services, and likewise. Now, when I look at the kind of metrics that they may target, each of these buckets may target, from a platform engineering perspective, we would be looking at developer productivity, because that is what we are creating the platform for. We'll be looking at the availability of that platform itself. Whereas when I look from a DevOps lens, I'm looking at an increased deploy frequency, right? I'm looking at the lead time, which needs to come down. And when I'm looking from an SRE perspective, I'm looking at things like your error budgets and SLOs and likewise. Um, what benefits each of them are going to give back to the organization, let's understand that as well. So from a platform engineering perspective, it is the enhancing the productivity and the efficiency of your developers. From a DevOps lens, we are looking at simplifying this entire process of deployment. And from an SRE perspective, I'm looking at the frequency of the outages and likewise. So the trend that is emerging is that organizations that start their journey start with DevOps. They reach to a certain degree of maturity, and now then they have a platform team. And like I said, it's a typical hub and a spoke model, after let's say 1 to 1.5 years of the journey, where the hub is your platform team that continues to roll out the services, and spokes are your feature teams. And there is nothing like DevOps engineers in the middle. They were an ephemeral team, like I gave you that example earlier. Um, and the teams are capable enough of maintaining and managing some of the things by themselves, and they continue to consume the services by these platforms. The SREs will help in managing things like your error budgets and then the reliability and efficiency of your services. So this is the kind of pattern that I'm seeing coming from large and complex enterprises. Back to you, Dheeraj.
Thank you, Adarsh. And I think that kind of puts it together, the holistic view from our audience perspective around the cloud native platform engineering, the DevOps aspects, the SRE aspects. And I think it's also a good segue to our next segment about the role of security in cloud native platform engineering as well. Because, like Adriana was mentioning earlier, that security plays a crucial role in the development of applications within the context of cloud native platform engineering. And as organizations adopt cloud native technologies and architecture, it becomes imperative to ensure the confidentiality, integrity, and availability of data and systems. So, talking about the role of security in terms of the secure design and architecture, we talk about identity and access management, data protection, container security, secure APIs, threat monitoring, DevSecOps practices, and many more. Again, would like to go to each of the panelists here to share their inputs around the role of security in cloud native platform engineering. So I'll start with you, Adriana, this time, since you initiated the thread on security earlier.
Yeah, sure. So I think security, when we talk about security, we're talking about, I guess it can be broad, right? We can talk about who has access to our Kubernetes clusters, who has access to specific namespaces in our Kubernetes clusters, what can you do inside? But I mean, it doesn't have to be our Kubernetes clusters. It can be even inside like specific areas of our cloud accounts, right? Who has the ability to do what? Can I provision VMs? Can I provision a Kubernetes cluster? Can I go around and provision S3 storage? Or even making sure that we're doing things like securing, like running like code scans, right? Making sure that there aren't any vulnerabilities in our code, making sure that like our Docker containers don't have any security vulnerabilities as well. And then, and most importantly, being able to codify that. I think the most important thing is you know, the taking advantage of the codification that platform engineering that we get with platform engineering, but also speaking again, having those conversations with your security folks and having conversations with your engineers to like understand what that landscape looks like, because there's nothing worse than all of a sudden finding out, oh, I don't have access to do the thing that I need to do my job because somebody made some sort of unilateral decision, and now like you've just made the process like 100 times worse, right? So really making sure that you have those conversations with the people impacted by those changes.
Thanks, Adriana. Over to you, BMK, the role of security in cloud native platform engineering.
I think it is, you have to understand you cannot treat security as a separate item in your organization. I think those days are gone actually now. And I agree, Dheeraj, what you said, like security as design, secure by design. And I think you need to always think that like security is in every aspect. But like how quality is everybody's responsibility, security is also everybody's responsibility, from platform perspective, from your network perspective, your compute and storage perspective, your application developments, your data purpose. So I think security is everywhere, like that you need to understand that. That's number one. Number two, if people are thinking about like I just need to look at scanning my source code at a given point of time, and then if you think that I can certify myself I'm secure application developer, I'm sorry to say this, you need to switch to a mentality and mindset of called continuous security, right? Because there are a lot of new vulnerabilities and threats are occurring in the space, and you need to be aware of that. The code that you wrote 6 months before, or even 3 months before, or even yesterday, what is vulnerable now? For example, Log4j that we dealt in back in 2021 December, what it has taught actually, or what other issues like vulnerable packages that we had, like with your Java struts and packages. So you need to understand that you have one way or other these threats and bad actors, influencing in the space. So you need to be considering security. It's by default. You don't need to be. You don't need to say that it's somebody else's job. It is actually part of us. If you're an application developer, it is your job. If you're a database developer, it is your job. If you're a platform engineer, that's your job. So it's part of your job. That is number two. And number three is that you need to also catch up with the new things what's happening. For example, in US, or probably Adriana would be able to comment on this as well. Like recently, the federal government and federal agencies in the United States have declared that every software supplier provider, they need to comply to a certain standards, and also provide actually a SBOM, which we call software bill of material, of composition of what is making your software that I'm running. So I need to have a visibility of that, because they made it as a mandate. Is that right, Adriana? Right?
I'm actually in Canada, so I don't know.
Okay, yeah. So maybe so I think that this you folks
But
can look at that. The SBOMs is one of the things. So you need to understand what is happening from your software supply chain perspective, and then what are the possible attacks could happen on your software supply chain. Because people think that, oh, I'm writing software, only my software using a particular library, so my software could be. No, your build server could be compromised, your database production server could be compromised, your dev environment could be compromised, your ticketing system could be compromised, your network monitoring system could be compromised. So you could do that. Like, yesterday I was listening to in another webinar where people can hijack your network session, and they can impersonate as you, and they can buy things from Amazon using your credit card. So you need to be considering that. You need to be practicing DevSecOps. You need to be understanding the tooling and practices required from a security perspective in your entire software supply chain and your tech stack. I think that is more important for you.
Thanks a lot, BMK. And one of the things which you mentioned, which I want to highlight, because just few weeks back I was having this discussion with a big organization in Saudi, which were implementing a large-scale DevSecOps practice within their organization, and talking about those regular security assessments and penetration testing, because cloud native applications should undergo regular security assessments and penetration testing to identify vulnerabilities and weaknesses. And these assessments help uncover potential security risk and enable organizations to address them proactively. So thank you so much, BMK, for sharing that aspects around with many other aspects in detail. Over to you, Adarsh, to talk about role of security within cloud native platform engineering.
sure, thank you for that. And I think some of the thoughts that were expressed by Adriana and BMK kind of they resonate very well. Especially, I think one of the areas mentioned was the security shift left. I mean, if you get a security issue in production, according to the NIST data, it costs you $9,600. Whereas if you had the same defect in, let's say, a QA environment, it would cost you around, let's say, $960. So security shift left, that is extremely important. Now, what we have to understand, and like BMK also called out, that the attack vector has changed. In fact, what we look today is that the hackers are also, highly organized, and on an average, there is a 20% increase, year on year increase in on your CVEs. So what it means is that a lot of these issues that we are seeing, they have to be addressed a lot early and quick in the life cycle. So looking at things like, for example, your microservices and security around your microservices, looking at containers and the security around it, like Adriana just touched, and then of course the CI/CD pipeline and the security in and around your pipelines. So basics, extremely important. So when I talk about, let's say, microservices, looking at things like ensuring HTTPS, ensuring OAuth 2, along with your OIDC, and likewise. So multiple things using key vaults like Azure Key Vault or HashiCorp Key Vault to store your secrets. A lot of these tools, techniques, and practices need to be imbibed to make sure that the platform we have is extremely robust. And then there is a very important gating criteria, which is the process that we talk about. So ensuring that the right kind of quality and security checks and gates, and wherever possible, are automated. so that whatever goes into production is all sacrosanct. But at the same time, it shouldn't slow things down, which is why as much of an automation there as possible. So I think those are some of my thoughts around security within the cloud native platform engineering space.
Thank you, Adarsh. And like each of the panelists have echoed that security is everyone's responsibility. You build it and you secure it. So, quoting John Willis here. So, I think it's really something which you do not see it as separate, like we was saying. It is part of an embedded overall practice within the cloud native platform engineering. So, with that note, now it brings it to our last segment and also last 5 minutes for this webinar is talking about the future trends in cloud native platform engineering. And while I posted about this webinar earlier on LinkedIn, I also got a question from one of the peer LinkedIn fellow member about how generative AI, because there is a lot of hype around generative AI, will impact cloud native platform engineering. So, a brief aspect around it from each of the panelists would like to have it as part of for the audience references. So, quick note on future trends in cloud native platform engineering and how generative AI will impact it. So, we'll start with you, Adriana.
Yeah, so future trends of platform engineering. I want to see more things being codified. I want to see more policy as code happening. And definitely, I think there's a comment on observability with regards to platform engineering. I think you can't have platform engineering without observability because things break. And we need to understand why the things are breaking. So to leave out observability from the conversation of platform engineering is as bad as leaving security out of the conversation of platform engineering. And I think the main thing is I think each organization will have its own platform engineering journey. Because as much as we try to emulate how other large organizations do these things, it really is up to how you can do things in your organization most efficiently and will benefit your employees. And I think that's something really important to keep in mind. I think there's a lot of really great ideas out there, and we should certainly borrow them, but we shouldn't try to imitate them exactly, right? Everyone's got their own journey when it comes to platform engineering.
Perfect. Over to you, BMK.
So, if I understand the question, like I think the notion is that everything has code. Everything has code, including your platform, your infrastructure, your security, your compliance, your observability, your and whatnot. Everything is code. I think that is where more and more our industry is going towards, actually. So rather than you doing actually a manual eyeballing work or doing something like you start defining everything as actually a code. And I think that is where we are heading, and probably audience learning one or two things, scripting tools and understanding few things will help them in a long way.
Great. Over to you, Adarsh.
Thank you, Dheeraj. So I think from a trends perspective, I think it is important how things are evolving in the space that touch platform engineering. So, for example, within the cloud native space, the entire movement around serverless, I think that will have a massive impact because a lot of organizations are looking to move towards serverless because the things they reduce energy and likewise. So that is something that will have an impact on how platform engineering shapes up. The other thing is around some of the controls, and I think BMK also touched upon the SBOM. So some of these controls that are coming, so especially how, let's say, Dockers and containers are evolving, and how changes are getting bit to the WebAssembly. So for example, we don't want to run, let's say, an entire scan again. If I have, let's say, a number of my images, can I reach to a stage where some of my containers, we point out that these are the ones that we need to fix our CVEs, and we get automated pull requests to make sure that we fulfill and fix some of those CVE related changes and likewise. So I think those are the impacts that I see moving forward from a future perspective. And now coming specifically to your question around the generative AI, I think one of the important aspects here can be the release predictability, because there can be number of areas that may be affecting your release. So this could be areas around how you maintain and manage your requirements, all the way till your quality and security, what you've embedded within your code base. So I think that is where probably when you are moving towards a release, let's say 20 days before the release, if I can get to know that these are all the possible areas I need to course correct to make sure that the release happens successfully, I think that probably would be one of the big wins. And in fact, we are experimenting a lot with some of our customers on bringing that release predictability as part of the overall platform that we have, so that things go very smoothly for them. So those are some of my thoughts around this.
That's very interesting, Adarsh, and would be keen to hear more about those projects you're working with your clients around that. So I think Gen AI is expected to bring automation, optimization, and intelligent decision-making capabilities to cloud-native platform engineering, enabling organizations to build and manage highly efficient, resilient, and cost-effective cloud-native systems. And it kind of brings everything together as part of each of the panelists have shared during this session. So with that note, I would like to thank each of the panelists here. Thank you to you, Adarsh. Thank you to you, Adriana, and thank you to as well, BMK, for providing your time as well as your expertise in sharing almost everything holistically around cloud native platform engineering. Of course, we will have further segments to dive deeper on different aspects of it, being a wider umbrella, and keep on bringing, as we call it, as the new skills, knowledge, ideas, learning as part of this skill up sessions. And again, sincere apologies for the video and audio technical issues which we faced during this session, but ensure that that will be fixed for our next upcoming session on IT service management. So thank you so much once again, and thank you again to each of the panelists. I will see you next time for the next skill up session. Thank you.
Thank you,
everyone.
Bye-bye.
Take care. Bye-bye.
Bye.